path of the asteroid in the solar system. And when this happened, something for the first time started being a bit more unusual, because this object showed an orbit that had a possibility of coming close to the Earth. And in particular, it showed the possibility of having an impact with the Earth in a few decades from now. And this is exactly when we start paying particular attention to an object, because it becomes a bit more unique, a bit more unusual.
So you decided you needed some more data, you need to observe it, and then what happened next?
Well, this is a pretty routine process. And when an object like this gets a possible impact in the future, we, and not just us, like the whole world, tries to observe it for the following days and weeks and months. However, this happened for about a week. People kept observing this object. But unfortunately, unusually, well, sometimes it happens, but not all the times, the object moved in the sky towards the direction where the sun is in the sky. And of course, since the sun is bright and it's up during daytime, when an asteroid moves close to the sun is when we cannot observe it anymore. So in about a week after discovery, due to this motion of the asteroid in front of the sun, we could not observe the asteroid anymore. Unfortunately, it's a pretty small asteroid, so it's about 50 meters in size. So by the time it moved away from the direction of the sun in its motion in the sky, well, it had receded too much from the Earth, and it was too faint to see. So for the following few months, it was now invisible, just because it's a tiny object and it's way too distant from us to observe even with the biggest possible telescopes. So it kind of ran away from us before we had enough data to say something conclusive on it. We were stuck in a kind of limbo, with the object still being possibly in an impact course. We are, of course, not sure it is in an impact course, but we could not exclude it with the data we had.
And let's say, worst case scenario, it is on an impact course. What kind of damage could a 50-meter object do?
Well, this is actually pretty easy to estimate, because it has happened in the past. And the type of damage an object of this size can do on the ground depends on what it's made of. Asteroids can either be rocky or metallic. And fortunately, we have two real-life examples of either type. If this object happens to be metallic, the easiest example we can think of is a crater that is pretty famous in Arizona. It's called the Meteor Crater. It's a couple of kilometers in size, and it's a big hole in the ground in the desert, and that was carved by a roughly 40-50 meter asteroid that hit the desert of the southwest of the United States a few tens of thousands of years ago. So that's what it would do if it's metallic. It would release all the energy upon impact on the ground and carve a big hole in the ground, and of course cause destruction for all the immediate vicinities of that. If, on the other hand, it happens to be rocky, and we don't know that, because we don't know the composition of it at the moment, it will likely go through the atmosphere and probably explode in the atmosphere while getting subjected to the pressures of the entry into the atmosphere. So it will likely explode somewhere up in the atmosphere, maybe 5, 10, 20 kilometers up, and it will cause a shock wave that will propagate down to the Earth, down to the surface, and likely cause pretty significant destruction on the Earth. And here we have an example in 1908 in Siberia. Something that is now known as the Tunguska event happened, and we think it was an explosion of, again, a roughly 50-meter asteroid that just disintegrated in the atmosphere. And the result was a radius of 70 kilometers of Siberian forest was completely destroyed by the impact. So it's not a world event, it's not a calamity that will affect the planet, but it's a significant event. And that's why we care about